10 o'clock California time, or as Andy would say, it's top of the hour. Let's get started with Tech Talk Tuesday. I'm Dan Conger. I'm Baseline's training manager. And today I'm flying solo on our Tech Talk. And we're going to be talking about controlling Christmas lights with the Base Station 3200. You can do it with the Base Station 1000 as well. It's going to be slightly different. And then I want to expand on that one. So a couple things. This is season 2, episode 39. This is our second to the last one. Next week is our final episode for this season, and we won't be starting back up till January. So join us for next week, our last of this season. So the idea on Christmas lights and a Base Station 3200. We're going to turn this into, our standard half-hour show. If you're watching this on YouTube or you got something else to do, I did create a very short 5-minute Ask the Trainer video that's already on YouTube, specifically walking through this in a very, very short fashion. Today, we're going to expand on it and we're going to dive a little deeper on it. So if you just want the down and dirty on it, I'll link that video on YouTube as well, so you can catch that one. So I wanted to introduce you to controlling other devices, non-irrigation things, non-irrigation components with an irrigation with our controller, with the Base Station 3200 specifically. So probably the key thing on that is going to be a relay, and that's really how we're going to bring it together. And I just want to take a moment and talk about relays, and we'll switch to my overhead camera. And relays are integral in making this work. And this is a very specific relay, and I'll tell you why when we get to that portion of it. Relays are a electronic or a magnetic switch. That's all it's doing. It's going to allow low volts, very safe low voltage, 12, 24, 30 volts. And we're going to use that low voltage to control high voltage. Big thing about low voltage is there's no code requirements, right? So we can do whatever we want with the bicoder, and there's no code, and it's very safe. But start getting into high volt, right? That's when you want to involve a licensed electrician. So that's probably one warning on this one as we're going forward. Involve a licensed electrician, depending on the code in your area, on how you're going to work with this high volt. I come from a contracting background, and this is certainly with my contracting background, I wanted to do it all. So I didn't always use a licensed electrician, but that's my warning on this one. But relays are going to make this work. So let's get into actually doing this. So for that, I'm going to switch over to my overhead camera. Okay. So I've got my Christmas lights here that I want to run with the Base Station 3200. Well, how am I going to do that? Well, I already said we're going to bring that relay, but let's walk through the actual parts on here. I'm going to move this out of the way. So the first thing we got to have is a Base Station 3200. Okay, that's a given. I also am going to need a single zone bicoder. So this is a BL5201. This is a single zone. You could use a 2-zone or a 4-zone bicoder. It's just going to be so much simpler on you if this is the only device you're using. So, and then I'm going to need to connect this to a 2-wire path, right? So the red and the black need to go out to a 2-wire path that's connected to a controller. This is what's going to be doing the work, this side. So we've got our single zone bicoder. The next thing we're going to need is a relay, and we're specifically calling for a Dayton. This is a Dayton 5X62N relay. And the reason we have this very specific model numbers, this is the one we tested out. You could find another relay that will work. Absolutely guarantee it. There's lots of different relays. This one, we tested it and we know exactly how to wire this one up. If you want to use a different relay, test it out and figure out how to wire it up yourself. Our wiring diagram I'll share in a little bit is unique to this one. The other thing about relays is what's important about them is you need to have the right rating, right? So we're going to have a power coming in to turn on the switch, to turn on that relay. In this case, 24, maybe 30, closer to 30 volts coming from this. And that will allow our 120 to come in and pass through. So we're going to use 30 volts to switch 120 volts. And that's how we can do it, safely connect this, right? We're not running high voltage directly into the controller. that would definitely be more dangerous. This is much safer to use a low power to switch the high power. What's really common, there's a couple really common relays that you see in your life, right? You think about your an older car, you turn on the turn signal, and that clicking you'd hear, that's actually this relay clicking on and clicking off. Or again, probably older cars, the horn relay. The horn you press one switch and it would turn on a larger switch, and it's a way to isolate high draw or high amperage circuits and save one part of the circuit. So that's what we're going to be doing with this one. The other portion we need is we need some way to connect to this. So this is a Dayton socket, and this is a 5X825N. And I got both of these from Grainger. So they're nationally available, but you could definitely find this online. And you could find another one. This is going to allow us to connect wires onto this one. Okay. So that we need that. Then I need to have a high power supply. So for today, I'm going to be using a piece of extension cord that I chopped up. Okay. And this is going to be my power supply going into the wall. And here's my black and white lead that's going to be carrying the power in. So we'll move that off to the side, because we'll be needing that in a little bit. Okay, so there's my power coming in, and then the device, how I'm going to connect it to my power supply, to my lights. So in this case, I want to run the lights. Well, how do I connect this to here? A couple of ways to do that. For today, I'm going to use the other end of that extension cord. That'll be perfect. Okay, so I can do that. Reality, if you're doing this for on one of your projects, especially commercial, you might be connecting to an outlet, right? So we could run wire from this outlet to the relay, but I'm not going to use this today. I'm just going to keep it simple because I'm just doing this on my desktop. Okay, now what are we going to run? Well, here I've got my lights. So this is how I'm going to connect those two together. So that's easy. That's easy. There we go. Now it's plugged in. Okay, now I'm ready to. Now I've got an interface, a wire interface to my relay. So let's go ahead and wire this up and make this work. So we're going to start off with the relay or the relay socket. And it's going to be easier for me to wire this all in before I drop in the relay, and you can see it better. So I've double checked. I'll show you the wiring diagram that I've used, and I'll have to drop this in the show notes, but this is actually, I just printed this from our webpage, and we should probably take a minute and come off of this one, and I'll share my screen. Let's do that. I want to show you what this looks like. So I found this wiring diagram on our website, right? So I went to the resources page, and in the knowledge base, actually I just typed in relay, and relay takes you to this, which is kind of nice, or some other search term. And here it is, turning electricity on and off with the program. I'll put this link right now. I will put it in the chat so you can get it. There we go. It's in the chat, but also I'll put it in the show notes when I put this on YouTube. So that's what's great about this, right? Is all the wiring information is in here, and then it applies to this Dayton relay. Well, this is going to tell me right here how to wire this. Okay, so I'm going to take my bicoder, and let's take those. I'm going to start off with that orange and those black leads. Okay, so those are going to go to these outside screw terminals. We're going to put in the white, and I think we show a specific color pattern. The reality is I don't think it matters which order it is, because what's going to happen is we're going to send 30 volts into this one, and that's going to start the relay. And here's my power supply coming in, the white and the black. Okay, this one does matter in that I want the black to feed the black going out, and I want the white to feed the white going out. So I'm going to match those up. So there's the black and the white. Now, critical step here, or another critical warning step here. I am disconnected from the power supply, right? You don't ever want to do this on a live circuit. Okay, so I've got this side coming in. Now let's do the power coming out that's going to connect to our lights. I'm going to connect the black lead in, and then the white lead coming out as well. And what's kind of interesting on this particular relay, I could also use these inside terminals. And if I wanted, this time I want when the relay turns on, I want my lights to turn on, but I could have the lights turn off when the relay turns on. So this is almost like a normally open, normally closed situation. I could change these screw terminals and make the lights do something different when the relay is activated. That's it. It's wired up. So let's plug in the relay. And if you notice, there's this little socket here. It's a particular direction. So we'll match that up. We're wired up. So we've got our lights. My lights are plugged in. We're connected to the relay. This is coming in. This is going out to my controller. Now I can actually make this live. I can plug this in because I'm done working on the circuit. So as of right now, this black and these black and white leads are carrying 120 volts right. They're live right now. There is no 120 volts here yet until we turn on this switch. It's just like a wall switch. It just has a magnet attached to it. That's about it. So now let's activate it with the controller. Now, let's talk about that for a second. So how am I going to activate that? Okay, we need to turn on, somehow we need to turn on or activate that bicoder. How are we going to do that? We could set up a program, but we need to have this. We need to search and assign for that device, assign it to a program, probably its own program, and give it a runtime. So those are some critical steps that we need to do. So what happens when we energize that? Let's find out. Like that. My lights work. My lights are on, and my relay's on, and you can kind of hear that relay clicking. And I think the other thing that's kind of interesting is if you watch this little corner right here, that's going to turn colors. That's orange. And so what's happening is there's a, let's zoom in a little bit. I think we can do that. The relay is moving around. It's actually moving the contacts. And let's see if you can see that. Yep. You can actually see it moving around a little bit. So my lights are active. That's pretty straightforward. So let's come back too far. Okay. Now, running that in a program is kind of the next step, right? So we need to be able to set up a program to run it. Now, I think another question for y'all is, can I do that with conventional wire? Absolutely. That's really easy. So for that, on your conventional wire board, I need to have a connection to the common and a connection to one zone wire, one terminal wire. So I need to have one dedicated zone on here that I can use, and I need to run those directly to the relay. And honestly, the relay might reside in a cabinet or in a pedestal or something like that. We can turn that off. Then we do that. These leads would then run to the relay, and we would just skip that bicoder component, and that'll allow it to run. So I guess my question for you is, we're switching Christmas lights. What are some other things that we could switch? So I'm going to start off. So I'd love to hear some ideas from y'all. I'm running Christmas lights, but I was in Texas, and there was an outdoor patio, and they had some large fans that they would use to cool off the patio while you're out there drinking your beer. I thought, wow, we could do the same thing, right? We could take this, instead of running the Christmas lights here, and we could just run this into a fan and have a relay that starts it. So we could run the fans on a program. That's my thought. So what else could we run that's not irrigation? Right? We already know that we can run irrigation, and we know that we can start, stop, and pause irrigation. Any ideas that you guys have? I'd love to hear them. Throw them in the chat and take a look at them. So another, okay. So John thinks, so he likes fans, right? A humidity mister. Interesting. Interesting. So let's talk about a mister. So what's funny is, so John, I know John's in Florida, and a mister in the West, we use misters outside to cool people off. So on that same patio, instead of a fan, we put misters to increase the humidity and drop the temperature. That's not going to work in Florida, where you've got 80 and 90% humidity. It's only going to make it more humid. But maybe in a plant environment, you want to control it. So how would that work? Instead of, we would have you might actually just run it directly as zone. So if it was a 24 volt device that you can open, we don't even need the relay. It's if we're going to operate a high power or a 120 volt device that we're going to need the relay to interact with it. So misters would be great. A sump pump, that would be an interesting one too. Or a sump pump or any pump. So how about this one? A pump that runs a fountain in a kid's play park. So we want to turn on that pump and we want to run it via a program. Well, we already do pumps. So could we do any pump? Sure. It doesn't have to be an irrigation pump. It could be a fountain pump. Okay. So we've got a pump going. What's another way that we could start it? So if we think about the controller, we've got a timed program, and time is a start condition. That's all it is. That's a condition in which to start the program. What stops is that it runs out of time. So other start conditions that we can use. Anything? Would you want to start a sump pump on time? Maybe. What are some other ways that you might want to start a program? I'll start. There it is. Here's mine. We could use a coach's button, right? So we could use a coach's button. Now we're going to start getting real creative. A coach's button in combination with the relay. The relay allows us to start any high volt device, and a coach's button now is the start condition. So how about that pump or that fountain, the sump pump or a kid's play fountain? You press this, it tells the program to start for the predetermined runtime. It activates the relay, turns on the pump runs, and then when the time runs out, however long you've told it, if you told it to run for an hour or 10 minutes, it runs, its program completes, and it won't start back up till it gets a new start condition, right? So Michael said, use a thermostat to run your fans. So that could work. So let's think about that one. So a thermostat is going to be low volt. It's going to most likely, maybe depends upon the thermostat, right? So this is dependent upon the device. So could a thermostat directly control high voltage, right? So, well, if it could directly control high voltage, then we don't need a relay. We just kind of step out of that one. But if we want to use low volt, if it can't, we're going to need that relay to interact with it. But a thermostat would be a great way to run the fans. But let's think about this one. So if a thermostat is running our fans and it's still hot in the middle of the night and nobody's on the patio, the fans are going to run. Well, if we can run it through the controller, so just straight thermostat, it gets hot, the fans turn on, it gets cold, the fans turn off. That's great. Do you want them running in the middle of the night? Well, you could do another way. You could put a mechanical timer in there. But if we run that through a program, right? If we run it through a program, now we can put more limits. We can put water windows that would apply to that. We could put run days that would apply to it. So we can take those same parameters that we use to run a irrigation program, and now we can use them to limit when this runs. So I like that idea. Hey, I have one other thing that I wanted to show you was, this one took me a little while to understand the difference. So pump start relay versus a zone bicoder, right? So we've got two different things that are there's an overlap here, right? Does anybody know the big difference between a pump start relay and a zone bicoder? And I'll be honest with you, it took me a little while to really understand the big difference between these two, because they're doing similar things. Because we were using a zone bicoder to run their Christmas lights and not using a pump start relay. Well, pump start relay is designed to activate a pump. So it's not a VFD pump, but a pump that's either on or off, right? So this is what that's used to activate. Big difference is this is going to put out roughly 30 volts sometimes, and it's going to, it varies, right? It's going to put out a variable voltage through these wires. This relay, let's get this. If I don't get shocked, this is still live. There we go. This relay is really forgiving, right? It'll run on 24. It's designed for 24. This is a 24 volt relay, but it will also run on 30 volts. It'll probably run on 20 volts. So it's real forgiving on that one. So if you have a device that any relay, a zone bicoder or a conventional wire, right? The relay doesn't care if it's 20 volts or 30 volts, 24 volts, it'll be fine. So either of those are fine for relays. But you may have a device that very specifically needs 24 volts. Any variance on that is just going to throw it off. Pump start relay is definitely the way to do that. So pump start relay does not send power through. It only is going to switch. It's going to either allow it to run or not allow it to run. You need, with the pump start relay, you need a power supply. You need a 24 volt source, right? So on this relay, I was running the 24 volts to activate the relay itself through the bicoder or through the powered bicoder. This does not. So I have to use a external transformer in conjunction with this one. So obviously, if you can use a bicoder, that's going to be easy, right? There's nothing special about that. You might even have an extra one on the truck. Use that, or an extra zone, an extra terminal on your powered bicoder. That's even easier. So that's probably the biggest difference between those. Any other thoughts on ways that you might start your lights? So we talked about a program through a coach's button, but really we could use any sensor, right? So we could, how about this one? Could I use pressure? Could I use a pressure bicoder to turn on my lights? Yeah, actually we could. Now, I wouldn't want to use pressure to turn on my Christmas lights. Okay, now I'm kind of straying from my original theme today, but I could use pressure to turn on a light. So let's say I had a system that wasn't particularly smart, or my users weren't particularly sophisticated, right? We want to give them very simple stuff. Tell if the irrigation, if the water's running, tell me this. If the building's on fire, tell me that, right? Very, very simple. Well, we could say when the pressure drops, turn on a light. Just turn on a red light bulb. Okay. Pressure bicoder is going to tell the system that will be the input to it. And then we'd need a relay to turn on a light bulb. You've got a big red light and turns on, and now the person that's on site sees the red light. They know that something's gone sideways. So we could use a relay to do that. Wouldn't do it for Christmas lights, but definitely possible. I think that's the gist of what I wanted to offer. So I'm totally fine with being a little bit short today, but since Andy and Chris aren't here, what I'd like you to take away today is you can run any high volt device with the right relay, right? So if you don't, this relay for the Christmas lights was designed to run on 24 volts. It's running on 30, and it's forgiving on that. And this relay, specifically this Dayton relay, was designed to run 120 volt circuit out. But a pump relay, a pump start relay, is designed to run on 240 volts. And if you had something bigger, if you had something that was 440, you could run that with your irrigation controller. You're just going to need a relay that's rated for that amperage the amperage and the voltage you're trying to run. So the right relay. So here's one from Jeff. How about landscape lights? Can you bypass the lighting transformer and just use a relay? So first question is, could I run landscape lights from this? Well, that's easy, right? All we're doing is instead of switching Christmas lights, the transformer is going to plug into this one, or the transformers, we're going to be switching an outlet. That's easy. Of course you can. Now, what you get now is you get any device in your system, any sensor, pressure, a soil moisture sensor, temperature, coach's button, any of those things apply. We can apply water windows. We can apply all those other same restrictions we can offer to zones. And then the second question is, can you bypass the lighting transformer and just use the relay? So he's kind of wondering, I think what he's asking is there enough juice from this to run lights? Well, first of all, landscape lights run on 12 volts, not 24 volts and not 30 volts. So that's the first. And the second is there's not enough juice on this, right? Because lighting transformers are rated, well, with LED, they've changed, but they're probably 100, 150 watt lighting transformers for LEDs. There's no way. We don't even have that back at the controller itself. So short answer is no, you need a relay to switch a high volt on that. And as John just said, no, you can't do it. So thanks, John, for the short, my long answer, your short version of it. Okay. I will drop the link for this in the show notes on YouTube. So if you didn't even get a chance to look at where that came from, it'll be in there. But what I'd like you to take away from today is you can run anything powered by electricity, we can run with our controller, right? You just involve the right size relay. If it's really simple 120, that Dayton relay and Dayton socket work wonderfully. It's not a very expensive thing. You can wire it yourself. Definitely a good idea to involve an electrician in that process. And then figure out what devices you want to run and how you might want to start them, because you've got all those options up. That's it for Tech Talk Tuesday today. Take a look at YouTube for this recording and all the other recordings I've done and all the tutorials I've done. Additionally, if you haven't signed up for the virtual trainings that are going on, those are available at the Baseline HydroPoint/Baseline website. So we will see you next week back for the last episode of season 2. So be sure to join us, and Andy and Chris will be back with us. Thanks so much for everybody coming. We will see you next time. Take care.